And so from here, this is my equation that I'll be using to predict the population estimation for 1990. And so for that one, you have T is equal to 60, but I want to know what my population is. So we'll just do P is equal to 50,000, E to the 0.0135 times 60. And you want to plug this into your calculator, and the population estimate is going to be 112,500 people. And that is your answer. All right, you guys, let's go ahead and take a look at example number 3. Okay, so number 3 is going to be on the rate of decay of radium. And go ahead and pause the video and see if you guys can try it on your own. I do have the answer provided for you, so go ahead and do that. Okay, I'm going to go ahead and go over it with you guys because you can unpause it now. All right, so you have your years in T as your X value, and then the amount of radium as your Y value. So it's given to you that 60 milligram of radium are present now. So year 0, 60 is your first point. And its half-life is in 1690. So in 1690, half of that is going to be 30. How much radium will be present in 100 years from now? All right, so then my equation is going to be the amount of the change of radium is equal to K times R, which means I'm going to have a dr over dt equals K times R. Now you want to separate them, so I'm going to move the dt over to the right side, so K times dt, dr divided by R, so I'm going to have something that looks like this. Integrate both sides. Integral of 1 over R is ln R equals K times T plus C. We're going to go ahead and put an E on both sides. I know this is becoming a little bit mundane, and you're like, okay, this is the same thing that we do all the time. CE to the KT is your formula. Now, this formula is not complete because you still need to figure out what C is and what K is. And so we're going to go ahead and use the first point to find C. First point here is 0 and 60. So I'm going to have 60 is equal to CE to the 0 power. So that's going to be 1, C equals 60. Let's rewrite this. R equals, replace the 6 with 60, E to the KT. Now I'm going to go ahead and use the second point right here to find K. So I have 30 equals 60, E to the K times. And the year I have is 1690. Divided by 60 on both sides, 0.5 equals E to the 1690K. Let's go ahead and do a ln on both sides. So ln 0.5 equals 1690K divided by 1690 on both sides. ln 0.5 divided by 1690 equals K. You want to solve for K and figure out what that is. If you want to do it right now, that's totally fine. And K is going to give you a negative 0.0004104. Now that I have this, my equation is complete. R is equal to, you want to rewrite it, 60e to the negative 0.0004104 t. And my goal here is to figure out what amount of radium is left over when the year is 100. So let's replace this t with 100, plug it into your calculator, and you should have 57.589, and the unit is milligram of radium. All right, number 4, try this one on your own for bacteria. And your answer is given to you. It's 123,000 is how much bacteria you started off with. All right, let's go ahead and see how to set this one up. So we have time as my X and the number of bacteria as my Y. And if you look at this right here, it's not telling you starting at 0. What it's saying is that the number triples in 3 hours. And if at the end of the 12 hours, there are 10 million bacteria, so 12 hours, there are 10, I'm going to put 10 M in millions, okay, because it doesn't make any sense for me to put 6 zeros there. How many bacteria were present initially? So my goal here is to figure out if it's at 0, how many do I have here? But if I go back a little bit, it also tells me that in 3 hours, so when the time is 3, the amount triples, so 3C. Here, I'm trying to figure out how many I started off with at the very beginning of this. So looking at this part here, let's set up the equation. B prime equals K times B. So dB over dt is equal to KB. Separate the B's together. dB over B is equal to K times dt. We're going to integrate the left and right side. And you guessed it, ln B is equal to KT plus C. Now let's do the E on both sides. So when I do that, ln E cancels. Number of bacteria is equal to CE to the KT. So now this is the initial equation I start off with. Let's go ahead and see what we have if I use my first point. Well, notice I don't have 0 here, so I can't cancel the E as easily. So if I have no 0, then try to cancel, or actually not cancel, but try to find K. So let's go ahead and use this equation right here. And the reason I use this is because you have a C right here for Y. So you have a B right there. So I'm going to have 3C is equal to CE. Replace your T, K times 3. And the reason we do that is because you can cancel the C's. So then you have the ln 3 equals 3K divided by 3 on both sides. K is ln 3 divided by 3. Now that I have that, I'm going to go back to the equation right here to find C. So looking at this part here, rewrite your equation. B is equal to CE to the K. K is ln 3 divided by 3 times T. So let's plug it in. Your B is going to be 10 million equals CE to the ln 3 divided by 3 times T. T is 12. And you're going to go ahead and do the ln on both sides, which will cancel the E on this. And you're going to end up with actually, before I do that, let's go ahead and just reduce this down a little bit. CE, this entire piece here, put in your calculator, is going to be 4.394444. Then you're going to plug this in, E to that, this piece right here, is going to give you C times 81. Divided by 81 on both sides, you actually don't need E. I kind of jumped the gun a little bit. C is going to equal to 0.12346. So I'm going to go ahead and rewrite my equation right here. So B is equal to 0.12346, which is C. E to the K. K was 4.39444 T. And the question here is, when the time is 0, what is C? So you can replace that with a 0. E to the 0 is 1. And so this is your answer, but remember this is in millions. So you got to move this 6 units. 1, 2, 3, 4, 5, 6. So your initial bacteria is 12346 0, or 123,460 bacteria is how much you started. And if this bacteria continue growing and tripling every 3 hours, then in 12 hours, you will have 10 million bacteria. All right, you guys, that was pretty much it. If you would like some additional practice, I will refer to you guys to take a look at some of the textbook questions. But if you feel like you're not quite ready yet, then my suggestion is look at some of the examples that I have here, look at how the questions are set up, etc., and make sure you go through these here. Now, I told you guys as before that we're also celebrating Pi Day. So in Pi Day fashion, here's some statistics about pi. Pi is a ratio of the circle's circumference to its diameter. I even have a little song for you guys. And I have a little cootie catcher, which, I mean, if you're doing this at home, it's kind of hard for you to kind of cut this out. But just Google and see if you're able to answer these questions from the cootie catchers itself. Like, name the famous scientist that was born on March 14th. Well, probably know who that is because I have a picture of the person right there. All right, you guys, as always, stay safe and healthy and try to take care of one another. See you guys next time.